Hi everybody, my name is Memo Dorian and I'm going to be talking to you about building a voice user experience. I'm an evangelist from the Alexa team at Amazon, so without further ado, let's get started. First off, what is Alexa and what is an Echo? Alexa is the service that powers um, the voice interactions or voice experiences. An Echo is the hardware. Uh, Currently, we have several devices that integrate into the Alexa voice service. We have a couple that are far field, so the Echo Dot and the Echo. Both of them you can interact with by just saying the words Alexa, Echo, or Amazon, depending on how you have them configured. The main difference between the Dot and the Echo is that the Dot only has very small speakers and has a line out, and an Echo has a really nice speaker in it. They both have a 7 microphone array, and they do a lot of processing on what they're listening to, so beamforming and noise cancellation and all this, so it's a lot easier for them to recognize the invocation word. A Dot is more thought out of as something that you would plug into a pre-existing sound system or sound bar or something of that nature. An Echo is more of a standalone device. We also have devices that are push to talk, and the Amazon Tap is one of them. So it's a portable speaker. It doesn't have to be plugged into the power all the time. And you can take it around, but it also has a button where you press it to start in voice interactions. The same thing for both Fire TV Stick and Fire TV. These the remotes for both of those have a microphone button on there where you can press it and start an interaction. And all these devices use the same service, the Alexa voice service. Out of the box, Echoes or a Tap has a lot of really cool built-in functionality, from being able to interact with smart devices like Wemos or Philips Hue lights, or playing your music from Pandora, or listening to a book from Audible. And these are all pre-built experiences that you can start using day one and make it really compelling for consumers. But Echo really gets smarter, or the Alexa powered devices really get smarter when we get developers to build additional experiences for them. And for this, we have two APIs. We have one that's a smart home API, and it's really focused on the home automation, and we have multiple partners that we integrate really heavily with. Here's some of them, but by no means is this an extensive list. It's just kind of a informational slide. And what we're going to be focused on today is building skills that are really just software based, and we'll talk about that a little bit more in a second. The way the platform looks is one of the devices we've talked about interacts with our what we call AVS, or Alexa voice service. And AVS lives on our AWS infrastructure or AWS cloud. There we do all the natural language understanding and all this programming that we then use to trigger what we call skills. And these skills are third-party software built by people like you to give Alexa additional capabilities or functionalities. One thing that's very, very interesting, and we won't go into detail this time, but as you can see, there's a third category of device that's integrating into the Alexa voice service in the diagram. And it's, in this case, it's a Raspberry Pi, but it's meant to represent basically anything that you would want to build. It could be an iOS app, it could be an Android app, it could be custom hardware that you're building. And we do have specific instructions on how to do this for a Raspberry Pi on our GitHub. But the way we look at it, and the key message here is the Alexa voice service is not a closed platform. It's not only for our devices. It's a platform that's open for everyone. We don't charge for using it, and the way we envision it, or what we really want, is for it to power voice interactions for anything. So more and more we've seen partners and different companies start to get interested in this, to where they'll integrate it into their own products, and it's something that has us very excited. And the way a skill works, and that is what we're going to be building today, is the user says something like what's in the word bubble. The cadence or the structure has to be Alexa, ask, and then the name of the skill. So in this case would be Alexa, ask home automation to lock the front door. And what happens here is that audio gets sent to the Alexa voice service, and using some metadata and a model, an interaction model that we built using that metadata that was provided by the developer, we infer the meaning of what was said, what was captured in the audio, and with that we build a JSON call that we then send over to an AWS Lambda function that once again was built by the developer. It could be just any HTTPS web service. We're going to be talking about how to do it specifically for Lambda, because it's the path of least resistance. There's really not a lot of friction. It's free. It's easy. So we're just going to go with that. And then continuing with the flow, the Lambda function then executes some code that will verify the state of the house, and will also trigger our smart lock or whatever to switch from open to closed. Once we get the state back, is the window's open, and we kind of just move back through the same flow. The Lambda function sends back JSON to the Alexa voice service, and the Alexa voice service makes sure the Echo or the device that the user was interacting with reads out a payload that was part of that JSON. So in this case, it would read something like door lock, but the back window is still open. So to the user, it's a very straightforward and quick way to interact and check status for this custom built home automation skill. So in order to build a skill, we're going to need three things: intents, utterances, and the web service. And like I mentioned, the web service we're going to be building today is going to be a Lambda function that will live on AWS. And let me just segue quickly into what Lambda is. Lambda is compute service that's part of AWS, but instead of spinning up a server or an instance for you that is just sitting there waiting for a call and being kind of wasted for a long time, Lambda is meant to just execute code, so like a code container that has triggers, and one of those triggers fires, your code will run, and as soon as it's done running, the compute or your Lambda function will stop existing in a sense. So it'll always be listening there. It'll just be an endpoint on the internet that is listening for specific triggers and will only execute when those happen. And it's meant to be for like pretty short executions, but it's very powerful and very flexible. So like I said, what we need to build a skill are three things: intents, utterances, and the web service. What is an intent? An intent is just a little bit of JSON that defines a blueprint for what our skill can do. In this case, you can see it's just an intents object that is an array of intents, and within that array, each intent has a name and can have also a space for slots, and the slot is basically a variable. Then we have utterances, where they are a list of sentences that have a specific meaning within the context of your skill, and we are going to take all of those and build a model and do a lot of natural language understanding and all this to build a model that is not just the sentences you gave us, but a broader superset. So it'll be more robust and will contain a lot more possibilities than what you just gave us. But the more you give us, the better we can make that model. So we're going to match those sentences to one of the intents that is defined in our intents JSON, and this way we know that when someone says one of those sentences or something that has the same meaning, our intent will match what we defined in our intent schema. And the third thing we need is our web service. And in the web service, at the most basic level, what we're doing is just waiting for a JSON object and then reacting to it. Within the JSON object, we'll have a value that is an intent, and that intent will match one of the intents we had as part of our intent schema, and we can react to it. But what is important to understand is that we're not doing speech to text. We're not just taking what the user said and converting it to text and just passing it over. We're doing all this heavy lifting for you and understanding what the user said and getting the meaning from it, and then converting that into a JSON call. So it makes it really simple for you to take something from what the user said and then be able to react to it from your software. But you have to define these three pieces and make sure your intents match here. And I'm aware that in my slide there is an error. So it reads my color is intent in the intent schema, but then in the utterances and the web service I have my color intent instead of my color is. This of course would not work as I wanted to, and the portal that we will go into in a second will actually throw an error if we do this, but just imagine this is my color intent. So now I'm going to show you how you go about actually building a skill, and we're going to use one of our samples that we have published. It's called Alexa Color Expert, and if you Google that, it should be the first hit. So if you Google Alexa Color, I did Color Picker, but it's creating an AWS Lambda function for a custom skill. So to build skills, you need two accounts. You need an AWS account, and the free tier is perfect. If you already have an existing one, what we're going to do should not incur any costs. And if you're a brand new to AWS, it will ask you for your credit card when you're creating an account, but it's more for verification purposes. The services we're using, again, should not incur any costs. So I already have my account, my AWS account. I'm just going to log into it. And like I mentioned earlier, the service we're going to be using is Lambda, and it's part of our compute services. So I'm going to go ahead and just click on Lambda, and you might see a slightly different window because you won't have any functions, and I already have a few that I've been just testing around. But I'm going to create a new Lambda function, and I'm going to type into the filter here. These are all blueprints, and we have quite a few. But if you type in here color, it should show you the color expert blueprint, both for Node and for Python. So I'm a little more familiar with Node, so I'm going to go ahead and use that one for now. But when you're developing your own Lambda functions, you can use Java, Python, or Node. This is very important to make sure your event source type is set to Alexa Skills Kit. If in the dropdown for event source type you are not seeing Alexa Skills Kit, it's probably because you're not in the North Virginia region. For now, this is a requirement. You have to be in the North Virginia region. So just make sure you flip that over to North Virginia from whatever, and then you'll be able to select Alexa Skills Kit as an event source type. And the event source type is a trigger that will make our code that is hosted in Lambda run. So it could be multiple things, but for building skills, it has to be Alexa Skills Kit. Go ahead and click next. This name is just the name of the function. It's not. It won't be externally visible to other developers or other users or whatnot. This is just for your reference. So I'm just going to call this one Hackster Live. And like I said, you can choose different runtimes. I'm going to stick with Node.js 4.3. And this code is the actual blueprint that we're using, and we'll come back to it. But I want to finish configuring the function first. It's important. The handler is also an important thing to make note of. Index is the name of the file. So if I was uploading the file, this file would be called index.js, and then handler is the entry point to the to this file or to this JS function. So what I'm doing here is at the top I'm exporting a function called handler. So that's why index.handler. It's important to keep that in mind if you're changing the name of this function, or if you're changing the name of your file. You're going to have to change it within the handler configuration to make sure it runs properly. Then the role is also very important. We're very conscious about the security within AWS. So you have to give your Lambda function permission to, or a role that would allow it to execute. So I'm going to just pick this basic execution role. A new window opens, and you just have to click allow, and it'll create a new role policy for you. Then you can just leave the memory and the timeout as is. VPC is another AWS service, a virtual private cloud, and it allows you to group services within one cloud. We won't be using it right now. We'll just hit next. And this is just a summary of what we did. Again, the event source is Alexa Skills Kit. The region is North Virginia. The name is Hackster Live. Just a brief description, runtime, the handler, the role, and the memory and the timeout. So now I'm going to go ahead and actually create that. And now the function has been created. We have the code over here with a cell editor. We can edit in line. We can modify the configuration if we need to, the event source, and whatnot. So for now, we're just going to leave it like that, and we're going to make note of this guy over here, which is a ARN, and it's a unique identifier for this Lambda function. We're going to need that later. So what we've done right now is we've created an endpoint that lives on the internet that is waiting for Alexa Skills Kit event to trigger it, but we haven't built the part that's actually going to send those events over to the to this function. So we're going to do that from a different account. Like I mentioned, you're going to need two. This is a developer portal for Amazon, and it's developer.amazon.com. If you use your Amazon credentials, it'll preload a lot of your information, but you'll still have to add a couple things in there. You might have to go through 2 or 3 screens. It's pretty self-explanatory. I'm going to sign in, and here you're going to have to go to Apps and Services, then go to Alexa, and finally to the Alexa Skills Kit. Here we're going to add a new skill, and we're going to make sure in this first tab we select Custom Interaction Model, because we're building a custom skill. We're not building a smart home skill. And we're going to call it Hackster Live. And this name, once again, it's just for my reference. So when I have a list of skills, I know which one's which. But this invocation name is very important. This is what the users would say to get our skill started. So it's analogous to if you were building an app, it would be like the icon for your app. You want something memorable, easy to remember, easy to say. So there's some requirements. No special characters, no numeric characters. That it doesn't contain the words Alexa, Echo, or Amazon. It shouldn't be over 50 characters, and it shouldn't be longer than 3 words. We also make sure not to use any copyrighted material or whatnot. So I'm gonna just what are we gonna call it? Since the word Hackster isn't a real word, I'm not sure how it's gonna handle it, but let's just call it Hackster. I think I did this for one of the other demos, and it worked fine. So hit next, and then we get to this point, whereas we're going to be adding 2 of the 3 things that I mentioned. And like just recapping, the 3 things I mentioned was we needed intent, utterances, and the endpoint. We've built the endpoint right now, and then we're gonna build this intent schema and the sample utterances. I'm gonna cheat, and I'm gonna use this entry we have in our docs that has the sample for creating an AWS Lambda function for a custom skill. The first part here is just showing you how to do the Lambda function that I already showed you how to do. So I'm going to scroll down to this part with the sample interaction model, and I'm just going to copy this, and I'm going to paste it in here into the intent schema. As I mentioned earlier, this is just JSON. We have an intent array, and within the intents array we have my color is intent, and what's my color intent, and an Amazon help intent. So we're like you see both in the what's my color intent and the help intent, we're just defining the intent, and within the my color is intent, we're defining a slot that is of name color and of type list of colors. So this is just a space for a variable, but the intents in themselves, we're not adding any more information. We're just saying what intents we have. So very basic, quite simple. Then in the sample utterances, what we're going to do is once again we're going to cheat and copy from over here, and what we're going to do is add a bunch of sentences that within the context of our skill have the same meaning or have a meaning, and match them to one of our intent names. So I have all these for my color intent, or what's my color intent, and within the context of my skill, these all mean the same thing. Me asking the skill for what my favorite color is. And then the more I did this, the more sentences I added, and the more ways I found it, or found to say the same thing or convey the same meaning, the more robust my model is going to be. So this is okay. There's quite a lot of variety here. This is not that great. There's only one. My favorite color is. So this is very, very strict or very narrow. You usually want to have more of these. But even here, and I'll show you in a second, you'll get a model will be built. It won't just be this sentence. Finally, the last thing we're going to do is add a custom slot type. And like you can see here, within the intent is there's a slot of name color, and the type is list of colors. That is a custom slot that we will be creating right now. So I'm gonna add a slot type that is list of colors, and this of course has to match this exactly. And then I'm just gonna type in the first few colors I can think of. And right there, what I created was a new slot. And as you can see with the spinny wheels up here and down here, is you can, we're creating that interaction model for you right now. We're going in there and building the whole thing, and based on this information. So it's important that both this my color is intent matches this exactly, and what's my color intent matches this exactly. In the case of Amazon.help intent, that is a built-in intent that we already provided all these sentences for, so you don't have to do it. I'm actually going to add another intent that's a stop intent, and it's also a built-in intent that we provide you. So all you have to do is this Amazon.stop intent, and when I hit next, the model is gonna have to be rebuilt, but it allows us to do some stuff while it's building the model, so you don't have to wait. When we finished building our Lambda function, I said we were gonna make note of this guy, the ARN. So now is where we need it, and we're gonna just choose that Lambda ARN and paste this ARN back in there. And what we're doing here is we're just pointing this. We're pointing these events back over to our endpoint. So we previously had an endpoint that was waiting for events. Now we have something that's sending those events over. For now, we're going to pick no to account linking. Just click next. And at this point, we're basically done. We've built a full functioning custom skill for that is voice enabled. In case you haven't received your echoes yet, you can do all the testing you want from here. This is what we call the service simulator. So in this case, you can just type in here my preferred color is silver, and I'll ask Hackster Live. And what it does, it's this JSON is generated. This is the JSON that would get generated when when our user speaks this and gets sent to our endpoint, to our function. And as you can see, it's got a session ID and application ID. This application ID is unique to your skill. It has a user ID, which is randomly generated each time a new user enables your skill. And then within here we have the type. It's an intent request, and then within there we have an intent, and it's my color is intent. I was telling it what my color was, so it matched it to my color is intent. And finally, we have a slot in here that has a value of silver because that's what I said. And on the way back, this is the Lambda response. This is what I got back from my service. And it's got output text, output speech that is of type plain text. And the text is, I know your favorite color is silver. You can ask me your favorite color by saying, what's my favorite color? So if I click this little handy dandy button down here,
I now know your favorite color is silver. You can ask me your favorite color by saying, what's my favorite color?
you can hear what she would say. So even if you don't have an Alexa, or I mean, even if you don't have an Echo, you can test Alexa and hear all the interactions by using this simulator. At this point for development, this is all we need. These last two tabs are additional metadata for publishing. We look at all the skills closely, so we have actual living, breathing human beings looking at them and evaluating and in a sense certifying them for us before they are made live to other people. But if you do have an Echo and you set it up with the same credentials you did for this portal, for the developer portal, you can just use your invocation now and use it on your physical Echo. So you can test that out. It's really cool for development and for testing your own skills at home. Now let's take a look at the code that was generated here. The code is quite simple actually. What we're doing is basically two sets of ifs. So we have this if, and if the request type, and this is all coming from the JSON, is launch request, we're going to call on launch. And what we do in on launch down here is we get a welcome response. And that welcome response is just us setting the speech output to welcome to the Alexa Skills Kit sample. Please tell me your favorite color by saying my favorite color is red. And we're also setting this reprompt text. What this reprompt text does is that Alexa has an 8-second timeout. So if she asks you a question and you don't reply within 8 seconds, or you say something she doesn't understand, this reprompt text is going to get piped down by default without you as a developer having to do anything else. So we're basically just prodding the user to give us a response. We're also we're sending this flag should end session to false, and this is we don't want the session to end. A way to think of them is like a conversation. So when it's done, the conversation's over, and Echo kind of goes back to not listening to what you're saying. So in this case, we don't want that to happen, so we set it to false. Now, if instead of having a launch request, we have an intent request, what we do is we go to on intent over here. On intent is basically just some more ifs, and what we're doing is checking what the value within that intent name, which is just within the intent request. We're checking the name to see if it's my color is intent, what's my color intent, help intent, or stop intent, or also cancel intent. So if it's my color is intent, we're going to go to set color in session, and what we do is within set color in session is we check we actually have a value for that slot, so there's something stored in there. If there's not, we have her say, I'm not sure what your color is, to have the user try again. But if it does, I now know your favorite color is the value, and we prompt them to ask us what our favorite color is, or what their favorite color is, which would be what's my color intent. And in that case, we just get the color from session. In both cases, what we're doing is we're leveraging the session attributes. and it's just an object, and we're adding a key value pair in there called favorite color, and we're adding the favorite color just so we're ferrying this information back and forth. And the session object is something you can leverage yourself to be to track what intents your user has said before or different information you're asking. And it's important to keep in mind though that it's volatile. So as soon as the session ends, those session attributes are lost. So it's only meant to help you track within one specific session, but it's not persistence in any way, shape, or form. So yeah, that's kind of the basics of the skill. I'm also going to go a little bit into some voice design tips for you. So it's important to keep in mind that it's very early days with when it comes to voice design, and the way you should think about voice is it's a different user interface. So we're very used to graphical user interfaces, but this is just a voice user interface, and it's like I said, it's early days, so we don't have all the different design patterns we already have for graphical interfaces, and sometimes it helps a lot to actually think these things from a user's perspective rather than just from our development side. So phrasing is very important. Making sure your phrases are not like odd or too lengthy, because users will forget them or will have a hard time saying them, and even though they're trying to use your skill, they won't be able to, and they probably won't try to come back to it too many times. So it's something that you should really keep in mind. So in this case, we have Alexa to just trigger her, and then ask Dave facts for a fact when the fact is of type Dave fact. That is a mouthful, so that's very, very hard to say. It's a lot easier to say, Alexa, ask Dave for a fact. And that is much easier, and it's also much more memorable. So if I wasn't reading this first one, I wouldn't even be able to say it off the top of my head. So it's just important to keep that in mind. You also don't want to do lengthy invocations. So saying something like, Alexa, ask transportation service alerts for the current status of the monorail A is very hard to remember, and it's also a mouthful. So you could say something like, Alexa, ask Traffic Buddy about monorail A. That would, in a sense, convey the exact same message, but in a friendlier way. So transportation service alerts is not very easy to remember. You'd probably think if you were trying to remember it, you might like swap the words around or something. Traffic Buddy is a lot more friendly. And then for the current status, I mean, the current status is just what's happening right now. So if you just say about, you've summarized a lot of it. Also, avoid repetitive invocations. So with voice user experience, you really can't look at all the options you have and then choose something. So you got to make sure you're very succinct, and you're not making your user say multiple things or say the same thing multiple times. So in this case, Alexa, ask developer info for a developer info. So if we had a skill called developer info, we could just have the user say, Alexa, ask developer info, and then we could ask some like follow-up questions if we needed more information, but just let the user engage with it in an easy way, and not have them repeating the same thing. Also use definitive choices. So make sure the user knows what their next action is. So I'm sure this has happened to you multiple times. And in my case, like I speak Spanish and English, and it's happened to me in both languages. So I'm fairly confident this happens in multiple languages. But if you ask someone, would you like fries or a salad, or would you like a soda or a beer, and they say yes, what does that mean? Yes to the first option, yes to the second option. So it's even as a human, it's very hard to parse that. And usually, if you're in that scenario as a human, you're gonna ask for clarification. Yes, what? But in this case, we don't want to have to like account for all that flow. So make sure the user knows that you're expecting one of the two options. So which would you like, fries or a salad? So you're prodding them or moving them towards the answer you actually want to hear, rather than the just leaving it really open and having them say something else, and then you have to do a bunch of error handling, and it's not as clean of an experience. Let's say you also want to leverage automatic learning. So let's say we have Travel Buddy, and I say Alexa launch Travel Buddy, and it'll go into, it's the first time I'm using it, so it'll go into a welcome message, and it'll tell me what it can do. So it's going to ask me where I'm going from, so I'll say Philadelphia, and where are you going? So I'll say Boston, and then it'll tell me, okay, it's going to take X amount of time, and this is why. So the first time, that is a great interaction, but you don't want to go through that every single time. So the next time I launch it, it should be something like Alexa launch Travel Buddy, and then it should just say your commute is currently 5 hours and 2 minutes. So it already knows the information I gave it in a previous session, and that should be saved in or persisted in some kind of storage. A very easy one to use is DynamoDB, and I'm gonna set up a quick another like demo for you guys where I'll go over how to use Dynamo in case you want to do this. But for now, just keep that in your back pocket. DynamoDB is a very easy one to integrate into Lambda, and if you Google around, you can probably get it up and running in an hour or so. You also want to do proactive explanations. So certain things won't fit the ask model. So you don't have to use the word ask. The words you have available are we have a page for them, but it's launch, open, start, ask, tell. So certain of those will be better suited for your skills names than others. So you gotta make sure you can explain to the user what's happening. So if I just say Alexa launch wagon rides, it's a launch intent like we saw earlier. So we want to like welcome the user and let them know a few of the things we can do. So you can ask it would reply to me. You can ask to get a ride or request a fare estimate. Which will it be? So just make sure you're guiding the user along and making sure you're holding their hand in a sense. You got to remember that for user interfaces that are graphically based, you're always looking at something. You always have a reference, and you kind of know where you stand within the app or the program. For a voice user interface, you're not looking at anything, and it's not as easy as one would think to remember exactly the words you said and how you said them and all that. So you have to be smarter on the skill side to keep track of all of that. Also, being concise is very important. Don't give users more than 3 options. I don't know if you do this, but what I do, like when I call the bank and it just starts rattling off options, sometimes they don't quite match what I want. So I'll always like hold out a finger, like if it's number 3 kind of sounds like what I want, but I'm not sure. So I hold out 3 fingers in my right hand and I keep listening to the infinite options. It's not a great experience. It's actually pretty clunky. So in this case, just don't give the user too many. Don't overwhelm them with options. Choose 3 and maybe give them one of those options is to get more options, right? In this case, you can say, let's say you've automated a ice cream machine that has voice now. So what flavor do you want? For chocolate, say chocolate. For vanilla, say vanilla. For strawberry, say strawberry. That's very convoluted. It's not natural at all. But you can just say, which flavor would you like? Chocolate, vanilla, or strawberry? But by just giving prompts like this and speaking naturally, people are going to just say one of the options because that's what the options you gave them. And then finally, using punctuation. So in this case, we're asking her for a joke, and if I just used plain text and just said, okay, your joke is coming in 321. What's black and white and red all over? An embarrassed skunk. That doesn't really work. So we have what we call speech synthesis markup language, and it allows us to control how she reads certain things. So what we did here is we took the same joke and just added the markup language. So okay, your joke is coming in 3, 2, 1, because we're interpreting this as a digit, and then we have a period here that's going to give us a pause. What's black? And then we have a comma that's also pausing. White and red all over, question mark. The question mark is going to change our intonation. A newspaper, also, exclamation mark, going to change the intonation. Get it, question mark. Red all over, period. And then say as, type spell out. So instead of reading this word just as a word, it's going to spell it out. So it's going to say, get it, read all over, R-E-A-D, and then, ha, I crack me up. So in the second one, we're actually telling a joke. In the first one, we're just reading a bunch of text that would be very hard to parse. So like jokes are all about timing. So being able to control that is very important, and you can achieve it using SSML. And that's it for the voice tips. You also more on the technical side, it's highly recommended for you guys to use the built-in intents. I showed you that a little bit on the when we're looking at the code. So Amazon help intent, stop intent, and cancel intent. Those are all three intents that are already built for you, and you can leverage them. And we've taken a bunch of sentences or words that mean help and kind of put them in there. But if you want to add your own, you can also add them to these intents. Let's say if there's something really specific for your skill, but it's really encouraged for you to do that. There's more of these. If you want to look at them, you can always just Google Alexa built-in intents. And that would be it for now. I am on Slack with all the ambassadors, and feel free to ask me. Paul's also on there. You can also find both of us on Twitter at Paul Kutzinger and at Memodoring. That second one is me. And we are also on at Alexa Devs, the broader team. I forgot to put that on the slide. If you want to take, we have a different sample we can guide you through, and some resources. If you go to bit.ly/Alexa Quick Start, we're always tinkering around with that one and helping people. So yeah, and if you have any questions or whatnot, make sure to find me on Slack on Hackster Live, and I'll be more than glad to interact with you and answer all your questions.